All right, let's try it again. Nope. All right. So I mentioned open system firmware this morning, and the goal of open system firmware is you own the machine, then you should own the firmware. There shouldn't be anything that you don't control because you paid for the machine after all. Remove the mirror.
Remove the mirror.
Ah, okay.
Remove that mirror.
Yep.
Arrangement. Yep, and just start a power.
Yeah, I think I can talk to it. So there are a lot of reasons for this. There's the security reason. We really want firmware to be a smaller attack surface than it is today, because right now it's a fairly gigantic attack surface. We want the ability to customize the firmware, and we might build special hardware, and we want to, control that special hardware earlier in the game, but we might not be able to, because I don't know how many people know this. There are a lot of systems you can buy today. If you change one bit of the firmware, the system will either brick, or in some cases, rewrite the firmware on the way up to change it back to what it was. It's kind of like got a little bit of memory. So it's getting harder and harder. If you look at a 7-year-old server, it's actually possible to change the firmware. If you look at a 1-year-old server, you actually have to go to the manufacturer and get them to make hardware changes to enable you to burn firmware into the server you just paid for. So that's kind of a problem if we're really talking at things like circular economy, because the whole point of a circular economy is, I've got it, I sell it to you, now you control it. But actually there's this long, thin thread of control that goes back to the company that manufactured it. You don't really control it. And if there are exploits and things in there, they're going to remain in there. So for reasons of security and a lot of other things, we want control of the machines. So at the OCP Summit in March 2029, we had a room. We got a lot of really interesting companies together. We had Microsoft, Google, Facebook, Amazon representing users more or less. We had ODMs, including Lenovo, WeWin, and others. And we had silicon vendors, which in this case were ARM, Intel, IBM, and others. And what we decided to do is work to a schedule that we thought was achievable in terms of building systems that the customer, the owner, controlled the firmware of. Now, my original goal for this was March 2020. Intel looked at me and told me I was nuts. But Intel, came back and said, we actually believe this is entirely achievable by March 2021. The thing you have to keep in mind is that means a lot of things happen. There are actually one-time fuses on the I/O controller hubs on the chipsets on Intel is the one I know most about. Once you burn them, once you burn a key in them, you can't change that key. So that's what kind of the core of bootguard is. We're really actually talking about selling machines where bootguard is disabled. That's the kind of thing we need to do. Further, the people that make the boards have got to sell us boards that don't have a BMC that just rewrites the firmware because it thinks something's wrong. So the people that make the boards have to make changes. So we've got a whole set of staggered things that have to happen at the chipset and the board level before we take the machine, we bought it. And the feeling is 18 months doable. Come up to the user experience lab. You can see some OSF systems in action, see how they work. So the schedule again, March, I'm sorry about this slide. It was self-referential, which I thought was kind of cute, but I can't show it to you, that's life. March 2019, we came up with the schedule. We presented it to the incubation committee of OCP in August. They accepted it. One of the most interesting things, one of the people on the board said to me, you're targeting servers and you're targeting maybe data storage systems. He said, I want it everywhere. He pointed out to me that every time one of his machines goes down and is not back in a certain amount of time, he gets to file a report with the FCC. And that's just something he really doesn't want to have to do anymore. So there was an interesting case where somebody said to us, I really actually care a lot about 20-second boot times and things like that. So that particular company wants to see every single system they buy from OCP running open system firmware. We're not shooting for that, right? We're shooting for the kind of one-use servers you see upstairs and data and storage systems. You, however, will also see an edge switch upstairs in the experience lab that has been running OSF for about a year now. So it's doable, but we're not actually trying to mandate that. So we have 3 stages here, right? We have the announcement, which is today, and then after that, 3 things. So in March 2020, we want vendors to announce that OSF is enabled. And all that means is I can buy it and I can build and burn my own OSF. I'm not asking them to do it. I'm just asking them to give me a machine that I can do it on. September 2020, we actually want to try and get to a situation where the vendors are providing OSF when I get the machine. Not requiring it, but we want to have some set of vendors that are willing to do this and give us a machine with that enabled. And then in March 2021, you must have the ability to buy a machine with open system firmware on it, or you will not be OCP accepted, period. Now, that's a bit of a scary thing, I know, for some of you. We believe this is actually a really achievable schedule. The schedule was really driven by the ODMs and Intel, kind of convincing us about what was possible, what was not. There shouldn't be a problem hitting this mark. At the same time, we'd really like to hear from you, any concerns you might have. And we also, as I mentioned this morning, are going to have a roadshow. So if you want us to come by and show you how to do this, I showed HPE about 2 weeks ago. They brought in a server, which they had actually reworked to disable boot guard. It's up in the experience lab. I had an engineer from HPE and me. We got the whole thing done in less than 4 hours. First time, I typed. They came back 2 days later. They typed and did it all. And again, they were done in less than a few hours. The hardest problem we had actually was just waiting for the Flash program to finish. So that's the schedule. What's the status? In this document we wrote, we had status. And we talk about compliant and not compliant. x86 is not compliant today with open system firmware. It's really close. It's super close on the Intel side. Intel's been working hard to relicense binary blobs like the FSP and the authenticated code modules. We're a little stuck right now on the manageability engine blobs, but the word I have is that's going to happen. Not sure what AMD needs to do and doesn't need to do, so we're not, I don't really know what the deal is there. We are talking to them and they do attend our calls. You're all invited to the call, by the way, it's bi-weekly. Open Power is compliant today. You can get all the source code for Open Power. You can burn it, build it, you can burn it. Now again, we're not requiring open source. This is a slightly different thing, but Open Power does give you open source and you can build and burn it. So Open Power is there right now. ARM, depends on the SoC, depends on the vendor. ARM is compliant in a lot of circumstances, but not all. And RISC-V is currently compliant, but I do want to emphasize, RISC-V is an unlicensed instruction set. That's great. It opens a lot of freedom up. Just because you have an unlicensed instruction set does not mean you're going to always be OSF compliant. It actually is quite possible in the RISC-V to build systems that don't have open system firmware and could not have open system firmware. So just be aware of that. A lot of people have expectations of RISC-V openness that actually don't really plan out. Finally, recent successes. I have a little build system. It's at github.com, Linux boot, mainboards. You can clone this. There are some directories in there with different motherboards. You cd into the directory, you type make fetch, and then you type make image.bin, and then you've got an image you can burn. So we've tested this on Intel Slim Boot. We've tested this. I've tested it on a Lenovo ThinkPad that runs Core Boot. The HPE system upstairs, we've tested it on that with actually a generic target. And what's cool about this model, by the way, is it's actually possible to build a generic target that'll boot on anything from an AMD server to an Intel server to a Minimax. We've done that as a proof of concept. So we do support UEFI, Slim Boot, Core Boot, U-Boot, and Opal, which is the Power 9 thing. We're finding this works. One of the companies that tried it out, and they said it was okay for me to say this, a guy from Netflix has a Tyan 7106. They followed the process. They actually gave us 1 or 2 changes. They did some commits upstream, but they discovered that this can work. So we're, again, happy to try and help anyone. And I have an open invite. If you want to visit me at Google, we do this. We set up in a cafeteria, and we just kind of, build the machine and burn it. Or in a meeting room if you don't want people to sort of see the machine you've brought in. And that's pretty much it. Again, open system firmware doesn't mean you have to open source the universe, right? It means, however, that if you have blobs, I can take those blobs, burn them into an image, give that image to a friend of mine somewhere else, and nobody's going to come and say you weren't allowed to do that because of restricted redistribution. So if there are blobs, they have to be redistributable. If they're a source, it needs to be licensed with an open source license. There can be no click wrap things where you have to click on a button before you go through to do it. If you go to github.com, you can find the Intel repo with FSP. It's just a Git clone, and away you go. And that's kind of the model. It's a Git clone of binary blobs, but that works. And again, we're here to help. Come talk to us if you have concerns or questions. We'll spend the amount of time we need to. We've got a lot of people from a lot of companies who are always ready to help. Thank you.